Hello all, my name is Rahman and welcome back to my YouTube channel. So guys, in this video we are going to build the SVM support vector machine from the scratch. So guys, if you remember in the last video, we have talked about the constraint optimization with the support vector machine SVM, right? But guys, I am going to try to implement those things in this video, or I will try to do that in the next video. But guys, with that I am going to build here the support vector machine from the scratch. So guys, to begin our support vector machine in Python, we have to do here some imports, like we have to import here the matplotlib, numpy, these libraries. Now guys, I'm going to use here the matplotlib for plotting the graphs and numpy for handling the arrays, right? So guys, let's go ahead and get started. First of all guys, I'm going to import here the numpy matplotlib. Let's import matplotlib .py plot as pld. Right now guys, below this one I'm going to import here the from matplotlib. Okay, from matplotlib I'm going to import here the style import. So guys, for importing these libraries here, we have to install these libraries. Like for example, let's import this first of all. Import the numpy. Okay guys, for running this one we have to install a library. We have to install this, like for example I should give something like pip install numpy. So guys, if we are using the Jupyter notebook or Anaconda prompt, Anaconda navigator, then you have to run something like this. If you are using it through this one, like for example I'm using here the command prompt for typing. If I type here something like, let's type, I should give something like pip install numpy. So guys, you should not give here the command lines here live, because you are going to get their errors. It will be asking you have to install the pip in the Anaconda prompt. All of things will be there, right? So guys, for doing this one you have to just type conda install numpy. You have to run something like this in the command line. If you are running that here, then you have to run something like this. Now guys, I have already installed the matplotlib and the numpy. So guys, if you have already installed, then you are going to get something like requirement already satisfied. Now guys, we have imported these things. Now let's run it. Now guys, below this one we are going to remove these things, and here I am going to use a style. Like for example, let's say we are going to use here the ggplot style. It's a style for the graphs, right? So guys, I have imported the style from here. So let's use something like style.use, and guys, in the brackets I'm going to use here the ggplot, something like this. And guys, if I run it, I'm not going to get any errors, because I have given here the use. I'm saying that use this data type. Now guys, I'm going to create here a variable dictionary, right? So guys, for creating I'm going to give here the name as dictionary data equals to, and then -1, because it's going to be a minus class here right now. After that I'm going to, instead of writing this one, I have written this some coordination for that one. I'm going to paste those things, and then I'm going to explain right now. So guys, here I have given something like -1, which is going to be a class, and then we have the numpy arrays. So guys, that's why here I have imported the numpy, right? Then we have the numpy arrays. We have these coordinations like 1, 7, 2, 8, 3, 8, and then again we have given the 1 np array, and then we have all of these things right now. Now guys, I'm not going to take it for, I'm not going to make it use here right now, because here we have to add here a class, and then we have to define some functions here, right? Now so guys, I'm going to make here some cells, and then I'm going to move this up here from here. Now guys, in this cell here, I'm going to create a class, CLSS class. But guys, you will be asking that what is class. If you don't watch my OP object oriented programming tutorial in the Python 3 intermediate series, then if you don't watch that, then watch that one, then you are going to learn about this one. Okay, now we have about the class. Now guys, let's create a class which will be something like svm, and then below this one I'm going to define a function, and that is def dunder init. Okay, so guys, this is it, and then guys, in this case here, what you want is you want here the self and we want here a visualization, right? So guys, for doing this, let's add here the self beside the visualization. VISUL visualize. Okay, now guys, visualization. Okay, now guys, here we have the visualization should be equals to true. Okay, and then here we want this true, and then guys below this one I'm going to use the self. So guys, here I have given the self in the parameters for using here the something like self dot visualization or something like that. Now guys, let's use it the self dot, let's copy this. Okay, and guys, self dot visualization, with this it's going to be the visualization only. Now guys, we want here the self colors, some colors, right? Now guys, let's add here these colors. Okay, now the colors will be something like I'm going to add here the blue and the red for this one, right? So guys, for doing this I'm going to use here the parenthesis flower brushes, and guys we are going to use here the one, and the first one is going to be in the red, which is going to be R, and beside that one I'm going to minus 1, which is going to be blue, B, right? Let's give something like, okay, now it's going to be blue here right now, and I forgot to add here this one. Now guys, we have created the class. In this case here we have to use here the if statement for the visualization. Okay, now guys, I'm going to use it if statement if the visualization, okay, if the visualization is not visualization, self dot visualization, and then it should be something like what we say, self dot fig. Fig means here figure here right now, and then it should be equals to figure. Okay, then we have to plot here the figure, right? FIGURE figure. Now guys, in the brackets nothing I'm going to give, and below this one I'm going to add here the self. Okay, self dot AX, and guys in the brackets, not in the brackets, self dot AX. Okay, and guys it should be equals to big self dot fig, which is self fig, right? Self dot fig dot I'm going to add here the subplot subplot. Okay, so guys, do you know that in matplotlib you can add here the subplots beside the graphs, right? So guys, I'm going to in the subplot I'm going to use the coordinations for the 1 1 1, right? Now 1 1 1 we have this one. Now guys, below this one here I'm going to define here a function which is going to be something like train fit, something like that, right? So guys, you have to do here the fit or training in the scikit-learn, right? So guys, let's create something like fit, and then in the brackets I'm going to use the self comma data for now, data, and guys I'm going to pass here this one only. Now we are going to do here the training for this one. That's why we have input this one. Now we have to import here one more. We have to define one more function which is very important, and that is the prediction. Alright, so guys, let's do that also. Predict. It should be something like self, and then yes, features. Now guys, here we have a question that why we are typing all of these things, because as I said before, we are in this video I am going to build the SVM, the support vector machine, from the scratch. So that's why for doing creating from the scratch we have to use this one. Now guys, here we have to do the classification. ICATION equals to, but guys, if you remember in the last video we have used a formula something like y sub I into x sub I into w plus b, something like that, right? Like for example, I'm going to show that in the comment sign you have used, right? And x something like x dot w x dot x into w plus b, right? We have used this one b, right? Now guys, if I show you with the zoom in, we have the sign w x into w plus b. Now guys, let's come back to here. Now guys, we have a question that how will you give here the sign in the Python? How do you write that? The main problem in Python programming is that we have to add here the signs. For example, if you have the multiplication symbol in your life, like for example, you are going to give something like x in your real life. Like for example, if you want to multiply the 1 by the 2, right, you are going to give something like 1 into 2, something like this in the book, pen or paper, right, in the paper. Now guys, if you have to do this in the Python, then for doing that one you have to give something like star, something like this. So guys, this is just for the small operators, but guys, what if you have the big operators, like we have the sign, right? How we are going to do that? So anyway guys, for doing this, let's use here the what we say numpy again, and then numpy dot sign, and then in the brackets you have to give something like dot numpy dot dot, and then np dot, sorry. So guys, here you will be asking that why we have given the numpy dot dot, because here we have used the dot product, right? This is the dot product, so that's why I have given here the numpy dot dot. Because if you see here, I have given the import numpy as np. I have done here this mistake. Now np we are going to use, np should be dot array ay, and then features. We are going to use here the what we say features. Okay, we have passed here the features right now. Now guys, after this one, what we have to do is we have to add here this self again, right? Now guys, let's add here this self dot w. So guys, we are doing the self dot w because we have here the x dot w, right? So guys, for doing we have to use the self dot w again. Now we have to do that with the plus b, okay, and then not b only, so we have to add here the self also, self dot b. Now guys, for doing with this one, we have to return here the classification. Return classification. Let's copy this, copy and paste it right now. Now we have the classification where we have the self, all of these things right now. Now guys, you'll be thinking that I am going to run this one, right? Now guys, I am not going to run it because here we have to here we have to do here some of the optimization here. So now I am going to add those things and then I am going to run it. Now so guys, let's do here the optimization for that. So guys, before doing that one, I am going to, if you see here, we have defined the fit. But guys, while doing the optimization, we have to fill this one, right? So we didn't fill anything for doing that right now. So let's add here something like self dot data dot, let's add here the, data should be equals to data only. And now guys, below this one, I am going to use here the option dict, opt dict. Okay guys, I am going to remove this pass here because we don't need it right now. Now guys, I am going to show you one thing, and that is, if I show you that here we have the what we say, now we have the magnitude of w, right? So let's see, here we have the magnitude of w, where now guys, in the object we have to do here the magnitude of vector w, where you have to give something like, I am going to give the value something like w comma b in this way, right? Now guys, we have the option opt dict, this one. Beside this, it should be equals to the flower process. It should be simple only. Now guys, below here I am going to add here a column known as a variable known as transforms. Okay, transform should be equals to, guys, instead of this one, I have given here some type of coordinates here right now. So guys, instead of writing all of these things, I am going to paste it because it's going to waste a lot of time. So let's paste it. So you can see here I have the transforms 1, 1, minus 1, 1, minus 1, minus 1, 1, minus 1. So guys, if you remember in the last video, as I said you, we can give something like 1, minus 1, minus 1, minus 1, minus 1, 1, and 1, 1. As I said you that we can also do that in this way, right? Now guys, I have done the same thing here right now. Now guys, what I'm going to do is I am going to add here I am going to add here some of the variables, and then I am going to do all of these things, right? Now below this one, let's add here a dictionary, right? So guys, for doing, let's give something like all data data. Okay, all data should be equals to blank here right now. And guys, below this one I'm going to use here the for yi in self.data, and we have yi in self.data. Beside this it should be nothing, and here I'm going to add the for feature set. Okay, and then in the self for feature set in feature set, something like this. Okay, now guys, sorry, for feature set in self dot, I have to give self dot data and then yi. Now guys, below this one, now we have to feature. Now guys, for we have to do here the FEA for feature in, we have to give the feature set. Okay, for feature in feature set, let's give the again this one. Now guys, here we have to do is what we have to do is we have to add here the self again, right? So guys, for doing this one, self dot max, something like this, with the feature and max feature value, we have to use here this one, max feature value. With this one it should be equals to max, and guys in the brackets I am going to use the all data. Okay, and guys below this one I'm going to do here its opposite thing, which is the self dot min feature value. Right now let's paste it here. Now instead of max, let's add here the min. We have the feature value, and here the same thing again, min, and we have to do here the all data for this one also. Okay, now guys, now I am going to give it the all data should be equals to none. Now so guys, what I am going to do here is add here the step sizes. Right, if you remember guys, in the last video we have drawn a ball, a type of bowl, where we have dropped a ball which will be going to the center point. Right, like that only we have done the stepping back, like we have drawn the from going back, right? Those are known as steps. Right, now guys, what I'm going to do is I'm going to add here those step sizes. Right, so let's add here the step sizes. Okay, it should be something around self dot, what we say, we have the self dot min feature value and max feature value. I'm going to copy these two things till here. Okay, now copy this one, and guys below this one I'm going to paste this one here. Let's paste it. Now guys, we have a question that why we are adding this self max feature value, all of these things, because what we want to do here is we want to give here the value of, we want to give here the size of those steps, right? So guys, that's why I am adding here the values here, something like this. So let's add here this one equals to, no need of this equal, and again here also we don't need this, no need of this equals. Okay, now guys, I am going to step this forward again. Okay, now guys, here we have the self.max feature value, we have all of these things, but guys, what we want to do is we have to multiply this into and 0.001, or we can give this, right? If you remember guys, we have done the big steps, we have taken something like small steps, and then we have taken these big steps, something like this, right? Now guys, so guys, for the big steps I'm going to use the 0.1, and for the small steps, this is the small steps for this one, it should be into 0.01. Okay, now beside this one I am going to add here again the this one. Okay, let's copy this one again and paste this again. But guys, here below this one I'm going to save it. Self.max feature value should be here right now, and guys, we are going to multiply this with the 0.001 because we have also taken these steps. Now we have done these step sizing. Now guys, we have a question that how many we want, like how many steps we want, 5, 10, 15, or how many, right? Now guys, for doing that one I'm going to give here something like the B range should be multiple. Let's give the range, then multiple. Okay, so guys, it should be 5. Okay, now let's give it as B only. Now guys, below this one again, B multiple. Okay, and guys, it should be also 5 again. Now we have these two things, right? Now guys, below this one I'm going to add here the latest latest, and guys, it should be latest optimum, optimum, and should be equal to self dot max feature value, okay. And guys, we have the max feature value right now. With this one I'm going to do here intro 10 again, and we don't need this right now. Now guys, what we have to do is we have to add here the for loops, right? Now let's do that also for, let's something like for step. Okay, now for step in step sizes, okay. And then below this one we have to do here is what to do, we have to give the value of w. Right now let's give something like array, numpy array should be in the brackets. I'm going to give it the latest, and guys, beside the latest optimum, okay, and then beside this latest I'm going to add here again the latest optimum. Okay, again pasted latest optimum. Now guys, I am going to give here again a value, and that is going to be optimized. Okay, so optimized should be equals to false. Okay, and guys, we have, if it's not also optimized, then it should be passed, right? Now while not optimized, let's copy this one, and I'm going to paste this instead of this one, optimized, and then below this one I'm going to pass here this one. Okay, so anyway guys, I'm not going to run this one first of all. So we have done the optimization, and I've done all of these things. Now guys, I have to add here some more optimization in this one. So anyway guys, that's all for this video. I hope you liked this video, enjoyed watching this video, and in the next video I'm going to do here some more optimization, and then I'm going to try to run that one there. Okay, so anyway guys, that's all for this video. Thank you for watching this video, and I will see you in the next tutorial. Thanks for watching. Thank you. Bye.